tutorial on regular expressions, explaining the basics of different regular expressions, and then we'll have a second video that sort of gives you some examples of different regular expressions. So to start off, fire up an editor of your choice. And what you're seeing on the screen right now is we're using the Mac terminal, because it doesn't really matter whether you're on the Mac terminal or Ubuntu, or you've SSH to the Raspberry Pi, or we were logged into the VPS. It's all the same exact process, because Perl should be installed on all of those by default. What you want to do is nano space, and what do we want to call the file? Let's call it reg.pl. Okay, so we're in reg.pl, and we're going to start with our shebang line. So hashbang /usr/bin/perl. And then below that, let's create a couple variables. So let's say hash space variable declaration. And then below that, let's go with sigil word equals double quote Apple, double quote semicolon. And then below that, let's create an array, and let's call this one at words, plural, equals parentheses, double quote, banana, close double quote, comma, double quote, apple, double quote, comma, double quote, peach, double quote, comma, double quote, orange, double quote, close parentheses, semicolon. Okay? And what we're going to do next is we're going to show the basics of what a regular expression looks like. And essentially, a regular expression is a little mini language that's used for pattern matching. So think of it as the guts of find and replace. And so there are three kinds of pattern matching regular expressions that you can run in Perl. We're just going to focus on two, which is matching regular expressions and substitution regular expressions. Okay? And so what I want you to do now is let's go ahead and type if space parentheses sigil word space equals tilde, which is the little squiggly line that goes over in yay. It's next to the, hold shift and hit the key next to the number 1 where the accent mark is. That'll give you a tilde. So shift or sigil word space equals tilde space m/a/ close parentheses, opening curly brace, hit enter twice, do a closing curly brace, and inside of there we'll put print space double quote, we matched the letter A, \n double quote semicolon. And sort of explain that regular expressions we have up there in our if condition. So you have sigil word, which that's the variable name, and then equals tilde. That's a binding operator to say, okay, make sure this regular expression or this pattern that you're trying to match is run on the sigil word variable. Okay? It's not equals equals or equals, it's the equals tilde. That's again a binding operator. Okay? So when looking at that regular expression, a matching regular expression starts with the letter M to mean that you're doing a match. If you're doing a substitution regular expression, it would be S, but it's the kind you're doing, a slash, and then the pattern that you're looking for. So in this case, we put the letter A, which means we're just looking for to see if the character A shows up. And then your closing slash that says that's the end of the pattern. Okay? There are other additional options and flags that you could put at the end of or behind that closing slash if you wanted to make things work in a global manner or in a case-insensitive manner. But in this case, we're just trying to match the letter A. That's all that's in that pattern in between those two slashes. So let's go ahead and save this with Control-O, hit Enter to save it underneath that name, Control-X, and let's go ahead and run this with Perl space reg.pl. And what do we get?
We match the letter A.
We matched the letter A. Thank you, Zach. Zach's here, by the way. So is Christina. And yeah.
Hi.
So what you saw there is that since sigil word contained apple, we were able to match evaluated as true, and thus it printed out. So let's go ahead and jump back in there again. Let's nano space reg.pl. And we're going to do this again, but we're going to go ahead and change it so that it says, as opposed to trying to match A, we'll try and match PP. So we'll change in between those slashes, we'll put a P and another P, and we'll change our print statement to we found a match. So if this works properly, we should expect that it still prints out we found a match because apple contains two P's right next to each other. Okay, let's go ahead and save this, rerun it. Found a match. Awesome. Okay, so let's tweak it again. Sort of show how this works. Let's go with, let's change it to, change our pattern to PLP. Save that. We'll rerun it. And what you'll find is that you don't get anything printed out because apple does not contain PLP. So again, what you're saying is it's whatever's between those slashes that is trying to match. Okay? Now, let's tweak this up a bit more. So let's change it. And so instead of PLP is the pattern we're looking for, we're going to put two capital letter P's in there. So M slash capital P slash. We save that and run it. We should get nothing. Mm-hmm. And that's because our the pattern we're looking for is two capital letter P's. And while apple contains two P's right next to each other, they aren't capital letters. So what we can do is we can jump back in. We can change our regular expression. As opposed to making those lowercase P's, what we do is after that last slash, we're going to put the letter I for case insensitive. Basically, we want to make it run in a case insensitive manner. This time when we save it and rerun it, we should get the fact that it found a match. And that's because we're basically saying look for two P's, whether they're uppercase or lowercase. And it takes some getting used to. You'll look at examples of different regular expressions online, and they sort of look convoluted, and that's because they're sort of a mini language within a larger language. Okay? So let's go ahead and let's do the same thing, but or a similar thing, but let's try and do a substitution regular expression. So let's jump back in, and what we'll do is we'll go below the closing curly brace of that if statement. We'll put hash space running a substitution regular expression. And in this case, what we're going to do is say sigil word space equals tilde space S slash capital P slash capital Y slash semicolon. And then below that, we'll say print space, double quote, we now have sigil word \n, double quote, semicolon. And when we run this, we should end up with the last line being, we now have apple with no changes.
Yep.
All right, so jumping back into the code, let's take a look at that substitution regular expression. So substitution regular expression is very similar to the matching regular expression, except for the match, you said M slash, and then you gave it a pattern to match or to find. The substitution regular expression is a replace process. So it's S slash the pattern that you're looking for, closing slash, and then what follows that is the pattern you're trying to replace it with. So we're essentially saying replace two capital P's with 2 capital Ys, and then the closing slash. So then there's 2 patterns there. Substitute the first pattern with the second pattern. But since it couldn't find capital P's, it didn't replace them with capital Y's. So let's go ahead and throw an I on the end of that to make it operate in an insensitive manner. And let's save it and run it. And we get
Ayol.
Thank you. So we get Ayol. So it actually did the replacement, okay, or the substitution in this situation. Okay. But again, there's a lot of different ways that you can play with regular expressions by saying, okay, if I'm doing a match, am I doing a substitution? And then if you give it 1 pattern, again, that's just for a match. If you give it 2 patterns, that's when you're doing a find this first pattern and replace it with the second pattern. And you still can drop those various flags on the end. The other flag that you'll sometimes use a lot is the G, and you'll see that in some tutorials. G just means globally. Okay? So for example, let's do this. Let's go ahead and let's go up and change up in our variable declaration. We're going to change sigil word to be equals, sigil word equals double quote apple space apple. So the word apple twice in there. We'll save that and rerun it. Now, what you should notice is that in our matching regular expression, it still functioned properly, even though there were 2 apples in there, because we asked, can you find 2-letter P's, whether they're uppercase or lowercase, but can you find 2-letter P's together? It can. Okay? So we got an it matched. But then for our second one, our substitution regular expression, we have
ale and apple.
Ale and apple. Okay, so if you'll notice, the substitution was performed on the first set of double P's that it found, but it did not do it on the second set of double P's. Okay, because essentially the match or the regular expression just occurs the first time it finds these characters or this pattern in string. So if we wanted to replace both sets of double P's, what we have to do is in our substitution regular expression, we change it where we make that after the last slash, instead of just I, we'll put GI. You can technically put IG, but GI is what you'll see most commonly. So GI, we'll save that and rerun it. And we get IL. Okay. That's essentially the basics of matching and substitution regular expressions. And it's really, again, it's a find and replace. And so this is useful, especially if you're doing, say, something like de-identifying information. You could say, okay, I want to look for instance, numbers in order to, say, blank out a social security number. Or I want to look for all letters and replace those with nothingness or with a star or something like that in order to de-identify or obfuscate information. Okay. All right, that's it for this short little quick intro to matching and substitution regular expressions. We're going to show you some different ways of using regular expressions in the next video.